Now we are going to discuss one small issue with the concurrent execution. Concurrent execution means what? Parallel execution. Okay. This parallel execution problem will come when we are using a sharing memory. Okay, shared memory system. Listen carefully. I'm just trying to explain the situation. Okay. Okay. Assume producer is there. Okay, one producer is there, and assume one consumer is there. They are sharing a small variable called counter. A variable can have only one value at a time. Correct? Counter may have only one value at a time. This counter value indicates number of process available in stack. Already we have discussed producer and the consumer will use a stack or queue, okay, to produce process and consume process. Now the number of jobs available in the stack will be indicated by one counter, one variable called counter. Okay. So counter value is 5 means what? In stack 5 process is there. Okay, in at any given time or at a given time, this stack is having at present 5 process. That means what? Consumer is having 5 process to consume. Okay, in other words, producer have already produced 5 jobs and that was placed onto the stack. This is the situation. Okay, now listen carefully. Producer wants to create a new process. Now, according to producer, what will be the counter value? It will become 6, correct? Now, producer produces new process means counter value will become 6. Okay, counter value will become 6. Okay. Now, assume counter value is 6. Now, consumer is coming and taking one process for execution. Okay, consumer is coming and taking one process for execution. Now what will happen? Again counter value will become 5. Correct? Are able to understand? Listen carefully. At time t0, producer is coming to the counter and mark the value as 5 and take the value 5 to producer program. Okay, to producer program because producer wants what is the counter value and producer wants to change the counter value to 6 because producer is going to produce a job. So producer is going to the subprogram, takes the value of counter that is 5 and coming to its own program, producer program, okay, and making it as a 6 and making it as a 6. Okay. So when producer is doing this, consumer is also coming and taking the value 5 to its own program. So consumer is now thinking counter value is 5. Producer is thinking counter value is 5. Okay, now producer is producing one job so that it makes the value 5 plus 1 6 and the producer updates the value to 6. Okay, listen carefully. Producer updates the value to 6. Okay. Now listen, what the consumer is having the value counter 5. Now what consumer will do? Consumer will consume one job and that will be made 4 because one job has been completed, consumed -1. Here +1, producer na +1, consumer na -1. Okay. Now consumer will update the counter value as 4. What should be the actual value? Producer is producing one job, consumer is consuming one job. So 5 will be 6, 6 will be 5. Actual value will be 5. Now see how actual value is 4. Suppose first consumer is doing this and the producer is doing this means it will become 6. But in both case, it will not be 5. Correct? And just think why this problem occurs. Okay, why this problem occurs. Same situation, if it happens like this, you see, counter value is 5. Okay, producer is coming. Okay, producer is coming, take the value 5 and make it a 6. Then he makes the counter value 6. Now after this, consumer is coming and making it as -1, 5. Now it is okay. Okay. So here I have used one word called after this. After this means what? After the updation of producer, consumer is updating means it is no problem. But when both producer and the consumer are doing at the same time, then only problem will come. That the same time is referred as concurrent execution. Okay. Concurrent means what? Working in parallel. So when producer and the consumer is accessing a common variable at the same time and updating also at the same time, now we will have wrong answer. Okay, the problem is two things. One thing is they are sharing a common variable, common memory. Okay, they are sharing a common variable. See, both variables are different means counter 1, counter 2 means that is different, no problem. But they are sharing a common variable, that is one problem. Another problem, they are sharing a common variable in parallel. Okay, in parallel, as I told, the output depends on what order access takes place. First producer and then, first producer and consumer is taking the data at same time. Producer updating first, consumer updating second means it will become 4. Consumer updating first and producer updating second means it will become 6. So depends upon the order, the data will change either 4 or 6, but both are wrong. 5 is the correct answer. This situation is called a race condition. Okay, this is the situation what we are referring as a race condition. So what do you mean by race condition? Instead of there is no any proper understanding between producer and the consumer, because they are sharing a common variable, also they are sharing it in parallel. Okay, unexpected output is coming, or unexpected answer is received by both the producer and the consumer. So it will create a confusion among these two processes. That is referred as a race condition. Okay, two more questions that they will ask. What do you mean by race condition? Okay, you know the situation. Now to solve that problem, we are using one solution called a critical section. Okay, you are providing one solution, or OS is providing one solution, that is referred as